The mechanism of electrophilic substitution across double bonds. Here shows a symmetrical alkene, ethene, which contains 2 carbons and 4 hydrogens. By looking at the reaction between ethene and hydrogen chloride, since the hydrogen atom is partial positive and the chlorine atom is partial negative, we can see that a pair of electrons is donated from the double bond to form a bond with the hydrogen. A carbon can form 4 bonds, and one of the carbon is now only formed 3 bonds, and it's positively charged. We call this carbocation. By receiving 2 electrons, the chlorine now becomes negatively charged. While the carbocation is positively charged and chlorine is negatively charged, chlorine is attracted by the carbocation to form a chloroethane. Finally, there are no major or minor products in this case, since they are formed by ethene, which is symmetrical. They will be the same even they are formed in different positions.
And here is another example of hydrochloric acid react with the compound beside it. And let's see what's the compound named. First, let's count how many carbon in it. 1, 2, 3, 4. And so it shows that there are 4 carbons in the carbon chain, and there is a CC double bond placed on the second place. And when there is 4 carbons in the carbon chain, it's named bute. And there is a CC double bond, so it is alkene. After knowing the functional group of the compound, we then need to consider where does the CC double bond place at, and turns out the correct name of the compound. The CC double bond placed at the second place, so therefore it comes up the correct name now, which is butene. After we have known the compound name, which is butene, we then look at how butene react with hydrochloric acid. First, both of them must turn into the structural formula. Okay, so now the structure of the 2 compounds are drawn. To go further, we should know how the electrons of the compounds moved, so that they can all bond together. Therefore, we now look at the electronegativity in the periodic table. And hydrogen is in group 1, so here is the hydrogen. And here is chloride, which is in group 7, period 2. Chloride is in group 7. It is the one who gains electrons from other. Therefore, the electronegativity of chloride is bigger than the group 1 element, hydrogen. And now, the hydrogen valence electron, which is the outermost shell electrons, had been shifted to chloride. Therefore, the polarity of hydrogen is slightly positive and chloride is slightly negative. And the next step is to find out how hydrogen chloride react with butene. So now let's think about how hydrogen get back the electron by replacing the one that shifts to chloride, and also how hydrogen chloride react with butene. Whenever anything react together, particles inside must be moving massively in order to find a chance and collide with each other at the right angle and right energy level. And now hydrogen chloride had moved just so near beside butene in the right angle and right energy level. They collide with each other. In butene, there's a CC double bond. There's 1 carbon of 1 valence electron was about to lose, and now so that they can collide with each other. Hydrogen chloride bond. Carbon has 6 protons and 6 electrons. The outermost shells of electron is 4. Double bond. There's 1 carbon of 1 valence and 1 bond was about to lose, so that they can collide with each other. The third carbon has 6 protons double bond and 6 in the carbon chain. The outermost shells of the electrons is 4. 1 share with hydrogen and 1 bond with carbon, which is in single bond, and 1 is double bond with the third carbon in the carbon chain, or the third carbon is double bonded with the second carbon in the carbon chain. Because there's the second carbon had lost one valence electron to bond with hydrogen, and due to the bonding with hydrogen, and due to the bonding with hydrogen, has broken. CC double bond has broken. The second carbon has now bonding with four hydrogen, now bonding with four hydrogens are now used up. Four valence electrons are now used up. The third carbon now has just only three. The third carbon now has just only three. One is bonding with hydrogen. One is bonding with hydrogen, with the fourth carbon, and two are bonding with the fourth carbon in the carbon chain. Therefore, more protons than the electron. The third carbon is in positive charge. After the hydrogen has bonded with the second carbon in the carbon chain, and now it left the chloride ion. The chloride ion is in negative charge because the hydrogen's electron have shifted to itself. To itself. Positive and negative charges may be stick together or bump into each other in the exact right way. Maybe the third carbon can swipe the electron from the chloride ion. So therefore, it turns out from that the negative.
The Markovnikov rule states that when a hydrogen halide is added to an unsymmetrical alkene, the hydrogen becomes attached to the carbon with the most hydrogens attached to it already. An example of unsymmetrical alkene is butene, where the number of carbon atoms attached at each end of the double bond is different.
On the other hand, butene is a symmetrical alkene because the carbon atoms at each end is the same.
By looking at the mechanism of the reaction between propene and hydrogen bromide, we can see that a pair of electrons is donated from the double bond between the carbons to form a bond with the hydrogen. By receiving a pair of electrons, bromine now becomes negatively charged. For the second step, we know that each carbon can form 4 bonds. However, this carbon only has 3 bonds. Therefore, this carbon atom is positively charged. This is called carbocation. Bromine carrying the negative charge is attracted to the carbocation. Therefore, they form a bond and the product is made. However, if the position of the hydrogen bromide and hydrogen is changed, this will form another product. By using the Markovnikov's rule, we can predict the major product of the reaction. By looking at this product, we can see that there are 2 hydrogens attached to the carbon. However, there is only 1 hydrogen attached to the other carbon. The rate of production of the major product is faster than the rate of the production of the minor product. This will be the major product and this will be the minor product.
Markovnikov's rule suggests that the first addition will take place on the carbon with the most hydrogen. In this example, the double bond will be broken during the formation of the product. Hydrogen and chlorine from the hydrochloric acid will be bound to the separate carbon while the double bond is broken. As hydrogen is in group 1, it can't hold more than 1 electron. Therefore, when the hydrogen is bound to the carbon chain, an electron will pass to chlorine. There are 2 types of product. The first product will be